Improving the accuracy and granularity of source data, then being able to share it via product carbon footprint is going to be very impactful in the way we measure and track sustainability goals globally. It lays the foundation for different stakeholders to make decisions that can help them achieve compliance, as well as protect and improve their brand. As we saw in the last video, without correct data sharing from its suppliers, a company could find itself at a competitive disadvantage and have an increased risk of damages. Overall, it is very difficult to evaluate a supply chain for improvements without clear and accurate data sharing. Dataspace concepts are derived directly from the challenges organizations face when contemplating sharing data scenarios with their partners and even their competitors. Data, after all, only provides value when it interacts, not when it is locked away at rest. Organizations want to maximize the value of their data to address both regulatory and business objectives. However, they want to be able to share this data in a controlled manner, with strong governance to account for data acquisition and its use. Also, organizations see opportunities to monetize the data they collect and manage if they have an environment that makes it possible. A dataspace is a composition of capabilities that define how participants interact with one another to form trusted data sharing relationships while maintaining their autonomy and agency over their data, commonly referred to as data sovereignty. Capabilities and characteristics of a dataspace are: 1. Participants in a dataspace have control over which data they share and with whom they share it, along with the policies governing its use. 2. Autonomy starts by controlling identity. If you're not in control of your identity, you can't act fully autonomous. 3. Participants need to decide who they trust on a case-by-case basis. Thus, data sharing is always peer-to-peer. 4. Participation in a dataspace must be based on rules. 5. Composing dataspace policies simplify the creation of trust. 6. Policies in a dataspace are well suited to provide guidance for data usage in AI scenarios. 7. No central system holds the keys to the entire dataspace or the ability to make arbitrary decisions on individual participation. And 8. Interoperability of heterogeneous environments is key to enable choice in an organization's implementation. Let's look at an example of how a dataspace can help address data sharing needs for carbon accounting. Although a dataspace can have multiple members, and an organization can be a participant in multiple dataspaces, we'll simplify our example between two organizations, the manufacturer of the widget and the supplier of the thingy. In the previous video, we demonstrated how the lack of transparency regarding how a PCF was calculated caused the manufacturer of the widget to be exposed to significant losses. This was because the supplier of the thingy only provided a PCF, or the answer, to the widget manufacturer and not the metadata about how the PCF was calculated, or the work done. Much like in a math exam in school, it is simply not enough to provide the answer, but also how the answer was determined for it to be valid. Let's see how, using a dataspace, the supplier of the thingy could securely share this data with their customer, the widget manufacturer. First, we start with the what we want to share. In this case, it is the data and the method used to determine the PCF for the thingy. In dataspace lingo, this is called the asset. An asset is wrapped in a usage policy that controls how the asset can be used once shared. For example, the usage policy may be that the data cannot be used to train LLMs or be shared with any other party, and must be deleted within 24 hours. Next, an asset and its use policy are attached in a contract policy that could stipulate data can only be shared in an environment that has specific settings for crucial sovereignty controls, like a data residency requirement that data must not be stored outside a specific jurisdiction. Once an asset is bundled with its usage and contract policies, it is ready to be listed in a data catalog, used by other organizations to discover data assets available to them. The key word here is available, as there is also an access policy that can restrict what organizations can even see the assets in the catalog. For example, the access policy may restrict visibility and access to companies that are verified customers of the supplier. The boundary of sharing within the data space is defined via membership policies, which govern what organizations can join a data space and negotiate data sharing contracts with other members. For example, the membership policy may be restricted to European manufacturers with a valid EIDAS ID. This composition of policies defines the environment for the possible sharing of the asset, i.e. the data and the method for determining the thingy's PCF, by its supplier to another party. So, in this case, the widget manufacturer, using their dataspace environment, joins this dataspace. And because they are a verified customer of the supplier, they can see the asset's availability for sharing and can establish a data contract with the supplier to access the data asset in their environment. Having access to this data allows them to discover the very favorable carbon footprint of material X and mitigate its use by bundling in a carbon offset with each widget until the carbon intensity of material X can be lowered or a replacement material is found. Defining data sharing in a data space is done by composing assets, policies, identities, and contracts together in a control plane. It operates on top of an organization's data platform, sometimes called a landing zone, where it maintains its own data estate, conceptually called the data plane. The control and data planes are integrated with each other so that when a data contract is in place, the subscriber or client of the data asset can work with the shared data as though it were locally present in their environment, based on policy, either as a synchronized local copy or a secure reference where it still physically resides in the other organization's data plane. Dataspace functionality is being defined by the International Dataspaces Association and an open standard established by the Eclipse Dataspace Working Group. Notably, Eclipse Dataspace components provide an open source implementation of the specifications as a framework for building deployable solutions. Integrating these components and applying them to the control and data planes allows organizations to build dataspace solutions and establish data sharing networks to address this and many other use cases.